Hello students. So AD0 to AD15, that means the 16 lines. These lines are multiplexed bidirectional address and data bus. So meaning that it is working as a address bus, also as a data bus, and it is multiplexed. And 8086 has 20-bit address bus A0 to A19. Okay. So A0 to A15, these buses working as a address and data bus also. So and A16 to A19 working as a only address bus. Okay. So 16-bit data bus. And starting from AD0 and from AD0 to AD15. So during T1 cycle, that means first cycle, carry lower order 16-bit address. So in the first cycle, it will fetch first the lower order 16-bit address. And T2, T3, T4 carry 16-bit data. So AD0 to AD7 lines carry lower order byte of data, and AD8 to AD15 carry higher order byte of data. So this is the all thing about the address and data bus. Next, AD19, AD18 and AD17 and AD16. Not so sorry, not AD. A16, A17, A18 and A19. These lines are multiplex address with status line. Previous address lines, what I discussed in previous slide, they are multiplexed with data and address. And these buses, that means A16, 17, 18 and 19 is multiplexed with status lines. That means sometimes it is working as a address bus, sometimes it is working as a status lines. Upper 4-bit address sent on the lines for memory operation. During input-output operation, these lines are low. What is the meaning of that? Suppose when we are working with input and output, in that time I needed address bus and data bus. Okay. So in that time, these lines, these status lines, is no need to work anything. But microprocessor is doing any internal work. In that time, this address and data bus are not needed. In that time, these lines will be activated. During memory and IO operations, status information is available on these lines in T2, T4 cycles. If I want doing work with memory related, we have to do this thing. So the status of interrupt flag indicated by S5. Okay. So there are 4 status signals are there: S3, S4, S5, and S6. The first we discuss about the S3 and S4. If S3 is 0, S4 is also 0, it is called alternate data we need to use. If S3 is 1, S4 is 0, in that time I have to tell the microprocessor the state data we are going to use. If S4 is 1, S3 is 0, in that time code segment register actually I am going to use. And if it is both are 1, 1, in that time data segment register we need to use. Okay. So segment S3 and S4, with the help of S3 and S4, we can able to use the segment address. If Both are 0, 0, alternate data. If 0, 1, stack data. 1, 0, code. 1, 1, data. Okay. So this is the uh, so again we are going to discuss about the pin number 34. So in pin number 34 is BHE bar. So if I give 0, in that time BHE bar will be activated because 0 bar means 1. Okay. So if I give 1, 1 bar equal to 0. Like that it will be happen. So if I give 1, in that time 1 bar, BHE will be 0. So in that time S, in that time S7 will be activated. During T1 state, BHE signal is used to enable data on most significant half of data bus pins. So D15, D8 to D15, S7 status information available during T2, T3, and T4. So what will happen if it is A0 and BHE? Suppose both are 0, 0, whole word from even address you have to take. If BHE is 0, is and A0 is 1, so upper bytes from to odd address. If BHE is 1 and A0 is 0, lower byte from to even address. And 1, 1, there is a no work. Okay. So next, the pin number 32, it is active low signal. Read strobe indicates that processor is preferred memory IO read cycle depending on S2 pin. So what is the meaning of that? The meaning of that simply it is the pin which if you want to read any data, we can able to use this pin. Simple thing. So what is read? Suppose if any data is suppose any data is already there in the microprocessor. If you want to just read the data, that means just access the data, it is called read operation. Okay, so this signal is indicated that microprocessor is doing the read operation. Next, ready. Ready means suppose if we want to do any operation through microprocessor, I need to know about microprocessor is ready or not. This pin indicated the signal which calls this microprocessor is ready or not. When it is high, carry out a normal operation. When it is low, freeze its bus and enter a wait state. That means when it is low signal, when the signal is low, in that time it is telling that microprocessor in freeze system, microprocessor in it frees its bus and enters a wait state. That means microprocessor not working. And when it is high, this pin is high. In that time, it is indicated that microprocessor doing the normal operation. Next is interrupt. So first of all, interrupt pin. So what is interrupt pin? What is interruption? Suppose microprocessor is doing some work. Between this work, any problem comes or user want to do some other work. What is more important than this work? What is microprocessor is doing presently? In that time, user can give some interruption. Okay. So in this interruption, it is called interrupt request. Before I'm doing user doing this, user can give some interruption signal. So this pin number 18 is it's called interrupt request. What is the meaning of this interrupt request? That means I'm requesting the microprocessor, please stop your current work or stop your current activity and do some work what I am giving to the microprocessor. Okay. So high level triggered interrupt request is in input I have to give through input pin I have to give. Check last clock to check availability of request. If request is not occurred, processor enters interrupt acknowledgement cycle. So in that time, microprocessor stop its current work and it will acknowledge the user that okay, I already stopped my current work. Now you can able to give me uh, your work. So after that, it will be one acknowledgement signal will become into the output. To see the output, user can understand that okay, microprocessor now ready for accept the any interrupt or it can able to pause its present work and it will go for the new work. Next test. This interrupt is examined by 8086 wait instruction. If test input is low, execution continued. If not, then processor enters wait in ideal state. It is simply the testing signal. So if it is low, that means execution continued. If it is high, in that time processor enter into the wait or ideal state. That means not working. Next, NMI pin number 17, non-maskable interrupt. There are two types of interrupts there. One is maskable interrupt and one is non-maskable interrupt. What is maskable interrupt? The maskable interrupt means microprocessor able to itself if able to itself rectify the interrupts or clarify the interrupt. It is called maskable interrupt. Some interrupts microprocessor not able to what is called, it is not able to rectify it or not able to manage it or handle it. In that time, it is called non-maskable interrupt. So there are two types of interrupts are there, maskable and non-maskable. NMI is not maskable interrupt by software. So that this pin, it will give you the non-maskable interrupt. That means it is not handled by microprocessor. It must be handled by user. So a transition from low high initiate the interrupt at the end of the current instruction. It is edge triggered input interrupt causes type 2 interrupt. So non-maskable interrupt means simply microprocessor not able to handle it itself, this type of interrupt. Okay. So some other pins I will going to discuss in my next session. Thank you.